Start recording. And we had just started to look at writing Lewis structures for ionic compounds. Yes? So when you are doing an ionic compound, this is on page 91, number 6. That was your homework. I want you to check your work and see if you would get full credit for it, for what you wrote. Okay, so we're going to mark it just the way I would mark on a test. And the way we're going to do it is we're going to use the little, where is it? Draw the Lewis structures of the atoms. So we're going to do atoms first. Then we're going to use arrows. And then we're going to show the electrons moving. And then we're going to draw the ions. And that's really the most important part. And then you can write the formula and the name. So atoms, arrows, ions. Got it? Atoms, arrows, ions. So let's go and do atoms, arrows, ions. So we have potassium. So we're going to draw the potassium atom. So atoms. And potassium is in group 1. So how many dots should it have? Everybody, tell your partner, potassium is in group 1. How many dots should it have? 1. Excellent. Fluorine is in group 17. How many dots should it have? 7. 1, 2, 3, 4, 5, 6, 7. So that was atoms. What comes after atoms? What do you do next?
Arrows.
Arrows. Who is going to transfer an electron? Who is giving the electron and who is receiving the electron? Yes. Potassium is giving and fluorine is receiving, okay? So we're going to show that electron moving into the empty space in fluorine's shell. Yes, because there's a gap there. So we have atoms, we have arrows, and now we're going to draw the ions. So what's left of K? Nothing is left in K's outer shell. What should we do with K because now it is an ion? Brackets around it. And what is its charge? Plus. Fluorine, is it empty or is it full? It's full. So we're going to draw fluorine. 1, 2, 3, 4, 5, 6, 7. I'm going to draw the other dot in a different color just so you can see that it came from fluorine, but you don't have to do that. And what does fluorine need? Brackets. And its charge. What is its charge? -1. All right, we're going to do a bunch more examples. Oh yeah, now we're going to write the formula. How many K's are there? 1. How many F's are there? 1. And what is the name of this compound? Potassium fluoride. And I'd like you to make sure you can spell fluoride. Try it. Make sure you can spell fluoride. Make sure it was U-O, not O-U. How are we feeling about that? Pretty good? Okay, so it goes atoms, arrows, ions, and then if it was on a quiz or a test, there would be a space that said formula and a space that said name, so you'll be able to tell where to write those. All right. Let's go back and do a couple of examples. Let us do Mg, magnesium and oxygen. Now, you can choose to just watch this. This is on page 89, or I think it would be more effective if you drew it along with, where did I go? Oh, there it is. So this is on page 89. Magnesium and oxygen. Magnesium is group 2. Therefore, we have 2 valence electrons. I'm just going to call those VE from now on. Oxygen is group. Everyone should have their period. Actually, if you don't have your periodic table out right now, get your periodic table out. And if you're lacking a periodic table, I will have somebody who can come grab one. Anyone need a periodic table? There's some free blank paper at the back. There's some blue box there. Okay. If anyone needs blank paper, it's free blank paper in the box at the back of the room. And if you need a periodic table, come and get yourself one. Okay, they're right up on my desk here. So oxygen is in what group? 16. Therefore, how many valence electrons? 6 valence electrons. So we're going to say magnesium, and we're going to draw 2 electrons, and you're going to tell me if I'm doing it correctly. No, what should I have done? I should have made sure that those 2 electrons were separate. Okay, group 16, 6 valence electrons. You guys are going to tell me if this is correct. No? What's wrong? Electrons do not pair up if there's still a blank space. So only one of them would go here and one would go here. So these are our atoms. What comes after atoms? Arrows. Now I'm going to show you what an arrow is not. Is that an arrow? No, why is that not an arrow? That's a line. What do arrows have? Arrows have arrows on them. They have arrowheads, okay? So I need to show that this is the direction. Remember the arrow head, okay? Where is that second electron going to go? It's going to go down to the bottom where we're missing one as well, okay? So that we have our atoms, we have our arrows, and now we're going to draw our ions. So metals lose electrons. What's left in magnesium's outer shell? Nothing. What do we have in oxygen's outer shell? How many electrons in oxygen's outer shell now? 8. 1, 2, 3, 4, 5, 6, 7, 8. You can put them in whatever order you want. Oh, hang on. I'm going to do something here. What do you guys think? Yes or no? No. Okay, you don't want them ever like sort of sticking out like that. They're always going to be like this. In fact, I'm not going to let you do this at this point, but later on, when you get used to doing Lewis structures, you can actually draw the pairs of electrons like this, but we're not going to do that for now because I want you to be able to count them individually, and it just gives one more thing for people to mess up on. You know what I mean? So we're going to leave that for now. All right, so there's magnesium and oxygen. I must be done, yes? Tell your partner, what am I missing? Brackets and charge. Okay, brackets, brackets. What's the charge on magnesium? +2 or 2+. And oxygen? 2-. Okay, good. What is the formula then for this? Formula is MgO. And the name is, tell your partner what the name of this compound is.
Abigail, my favorite.
I don't hear a lot of people saying the name. Half of you are doing it, half of you have not told your partner the name. What is the name of this compound? Magnesium oxide.
Oh, yeah.
Yes?
Yep.
No, not magnesium oxide, magnesium oxide. Excellent. Okay. All right. Now we're going to get tricky. Ooh. Sodium. And oxygen. Sodium's group 1. Oxygen is group 6. What's the first thing you draw for ionic compounds? Atoms. How many electrons on sodium?
1.
1. How many electrons on oxygen? 6. 1, 2, 3, 4, 5, 6. Atoms are done. Arrows. Well, I got this electron here. Off I go. I must be done now because I've run out of electrons. No. How could I fix this problem? Oxygen still has an empty spot right here. Yes. Add another atom. Absolutely. Okay. Add extra atoms as needed. So atoms, arrows, add extra atoms as needed. So we would need to have another sodium, Na, and that would help fill in this box right here. Okay. Now what we have is we have sodium. How much is in sodium's outer shell now? Nothing. Positive. Oh, but we have 2 of them, Na. Positive. How many electrons in oxygen's outer shell? 6. 1, 2, 3, 4, 5, 6. And I'm done, yes? Brackets. Done.
The charge.
I need the charge. Oh.
Oh, 2.
2. Oh.
I do it.
Okay. And now we're going to do the formula. Because we have 2 sodiums, it's going to be Na2O.
So you have to move it down.
Are you guys happy with what I've written for the formula? No, you're not. You didn't look at it.
On autopilot.
What have I done wrong? That little 2 is up top. It should be on the bottom. Okay, so I have Na2O and the name is sodium oxide. Okay, let's see where we're at. We need, I don't want to do MgBr2. Oh, let's do magnesium and nitrogen.
Oh, how does that work? No, I'm kidding. Like,
This is as hard as it gets. Mg. N. How many electrons on magnesium? Tell your partner, how many electrons on magnesium? 2. Yes, 1, 2. Tell your partner how many electrons on nitrogen. It's in group 15, so it has 1, 2, 3, 4, 5. So how many gaps are in the nitrogen's shell? 3 gaps. 1, 2, 3. I can draw them or not as I choose. Okay, up to you whether you do or not. Now we need our arrows. So I'm going to take one of magnesium's electrons and I'm going to put it into one of the slots. Don't forget your arrowhead. I'm going to take magnesium's second electron and put it into one of the slots. Okay. And now, I have a problem. How do I fix my problem? I have atoms and I have some arrows, but not everybody is satisfied. Remember, you can add what? Extra atoms as needed. Do I need an extra magnesium? Yes, I do. Okay, here we go. Mg. Do-do-doot, do-do-doot. Excellent. Here we go. Surely I must be done now. But I'm not. Who's unhappy at this point? Magnesium. So I need to add an extra nitrogen, because adding an extra magnesium won't help me yet. Okay, so add an extra nitrogen. And basically you're just going to go back and forth until everybody is satisfied. All right, so this one goes here. All right. Am I done? I still have a gap here and I still have a gap here. So I still need to add extra atoms. Who am I adding this time? Magnesium, Mg. Okay. And so now this one can go over here. And this one can go over here. And are we all satisfied? Yes, we are. And so now I can say I have 3 magnesiums, Mg, 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 bracket, 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 2 plus 2 plus 2 plus, and then I have nitrogen and nitrogen, bracket, 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 3 minus 3 minus. Are you happy?
No.
No, I forgot all the dots on the nitrogens, yes? Okay. The formula now is Mg, I have 1, 2, 3 Mgs. So I'm going to write Mg, 3. And I have 1, 2, N, so I'm going to write N, 2. Mg3N2, and its name is magnesium nitride. Would you like 10 minutes to work on this? Yes. Okay, so you're going to do the examples. Now, just before you go off into this, if you don't want to write out this quite so bigly, I know bigly is not a word, but I'm going to use it as a word. You can instead write 3 Mg, 2 plus, and 2 N 3-. That's another alternative, okay, that can make your life a little faster. Okay, so take 10 minutes. So at 1/4 we're going to move on to covalent bonding. We're just doing those. And then in 10 minutes, we are going to move on to covalent bonding. Yeah, you sure can. And if I see 2 people sitting around not doing anything, we'll start our covalent bonding immediately. So we're working on pages 90, 91. Yeah. Yes. Pardon me? The eclipse? Oh, maybe. I don't know. Oh, here, hang on.
I gotta see it.
No. Okay, so A, it's raining here, so you're not going to see nothing. And B, we are not like in the path of the total eclipse. Ours will only be partial. But here is a simulation for you. No, you're going to love it.
I gotta get my daily solar.
Okay, let's go home. Home. There we go. Okay, hang on. Can I make it bigger? Okay, we don't have to watch it again, but there is your simulation of the total eclipse. Enjoy. I hope that made your morning, because we're not going to be able to see anything from there. It is pouring right outside. Which is probably a good thing, because if you don't have the proper eye gear, you can damage your vision for Why are you misbehaving like this? Come on. Oh, for goodness sake. All right, my lovelies, we are on page 93. Okay. So we have just been doing ionic bonding. Page 93. Yes? Oh, we can go over that afterwards. Okay? Yeah. Ionic bonding. What kind of elements do you have in ionic bonding? Metal. And metals are electron givers. Yes? In ionic bonding, you also have a non-metal, which is nice because the metals are electron givers, the non-metals are electron takers. Isn't that nice? Electron givers, electron takers. But now we're going to have covalent bonding. And in covalent bonding, you have a what plus a what? Non-metal plus a non-metal. So you have an electron taker plus another electron taker. Oh my gosh.
You become a giver.
No, they don't become givers. They're both electron takers. So actually, I need someone to be a volunteer to come on up here. Volunteer? Sky. Thank you. Sky, you get a bonus mark on your next quiz.
Thank you.
Yeah. Okay. Now we're going to shut that so you don't get blinded. You can just stay there, okay? Because then they'll be able to see us. Now. You're going to be hydrogen, okay? And I'm going to be chlorine. 1, 2, 3, 4, 5, 6. 6, 7. Hydrogen, chlorine. Are you with me? If you're not looking up here, you're missing an important part of this. Hydrogen, chlorine. Okay, actually, no. You're going to start by being sodium.
All right.
Okay? He's sodium. He's got 1 electron in his outer shell. Yes? What kind of element is he? Metal. What do metals do? Are they electron givers or electron takers? Givers. And I am chlorine. I am a non-metal. I am an electron taker. Are we good? Okay. Now, hydrogen, chlorine, non-metal, non-metal. Okay, so that means we're both electron takers. So we're both trying to take both electrons. Yes, that is a covalent bond. Do you see how I'm pulling on the electrons and he's pulling on the electrons because my nucleus is positive and his nucleus is positive, and that's what holds the bond together. Thank you very much. You did a good job. All right. Sky +1 on quiz. So do you see the difference between ionic bonding and covalent bonding? Okay. And you can only share electrons if you have 2 electron takers. Okay? Because everybody's trying to take the electrons, and then they just both end up holding on to them. So, electron taker, electron taker, they end up sharing electrons. Today, we are dealing with only the most simple of Lewis structures. So let's take a look at hydrogen. We have hydrogen, we have hydrogen. And just like hydrogen and chlorine, they're going to come together and they're going to share those electrons. This is called a bonding pair of electrons. Where did one of them come from? One came from hydrogen A and one came from hydrogen B. Thank you, Anthony. Now, sometimes what they will do is they will show, and you're not going to be doing this for very long, okay, just in this first part where you're starting to understand it. Sometimes what we'll do is we'll show a circle around hydrogen A to show that it has 2 electrons, and we'll put a circle around hydrogen B to show that it also has those 2 electrons. And those of you who are on your phones right now, so both hydrogens now have a filled valence shell. Why is 2 okay for hydrogen? Why does hydrogen not need 8 electrons? Hydrogen needs only 2 electrons because shell number 1 needs only 2 electrons. Every other shell needs 8, okay? Now, instead of drawing it like this, we can replace those dots with a line. And I'm going to let you know that most people struggle with Lewis structures, so if you've decided that you don't want to pay attention for the last 15 minutes of this class, that would be a bad idea, okay? Can you guess what would happen with fluorine? They're going to share 1 electron each. So how would we draw that then? We would draw fluorine with its 1, 2, 3, 4, 5, 6, 7, and our other fluorine with its, and I'm going to draw them as little X's so you can see the difference. 1, 2, 3, 4, 5, 6, 7. Yes? What do we call that shared pair of electrons? That is called a bonding pair. And if we draw a circle around this fluorine, how many electrons does it have? 8 electrons. And if we draw a circle around our second fluorine, how many electrons? 8 electrons. We call 8 electrons a complete octet. What does the prefix oct mean? 8. Most atoms need a complete octet to be stable. So most atoms need a complete octet, in other words, 8 electrons in the outer shell in order to be stable. Who is an exception to that?
Hold up. Gotta get that bonus mark.
Oxygen? How many would oxygen need to be stable?
Unstable by themselves.
8. Let's look at our periodic table, shall we? Or actually, do I have the... Oh, hang on. Who does not need 8 electrons to be stable? You can check this out if you want to. It's on page 74, if you want to see it a little bit bigger. Tell your partner who does not need 8. And who else? There's one other. Helium. Helium is one of them. Who's the other one? Hydrogen, because hydrogen will fill up and it will only need 2 electrons.
So hydrogen is filled up.
Hydrogen is filled up with 2 electrons.
Oh, really?
Okay, so once you put a second electron in hydrogen, hydrogen is full because shell number 1 is full. Okay? There we go. Okay. So the exception, hydrogen. Two electrons fill up shell number 1. Is good? So most atoms need a complete octet. The exception is hydrogen, which only needs 2. So everybody needs 8 except for hydrogen, which needs 2. We will learn some other exceptions later on, but for today, hydrogen is it. Okay, so we can see this is just what we drew. This is just what we drew on the other page. 8 electrons on this hydrogen, 8 electrons on that hydrogen. And if we want to, instead of drawing our bonding pair as 2 dots, what could we draw instead? We could draw a line. That line is a bond. Is that a single bond or a double bond? That is a single bond. And how many electrons is it equal to? It's equal to 2 electrons. So if I was to draw it like this, I would say that I have 2, 4, 6, 8 electrons on that fluorine, yes? And I could draw my other one, and I could say I have 2, because that bond is 2 electrons, And then each lone pair, which we'll learn that word in a moment, is 2 electrons. So 2, 4, 6, 8 electrons. So it doesn't matter whether I draw it as a line or whether I draw it as 2 dots. That bonding pair is 2 electrons. Now, electrons that are not bonding pairs are called lone electron pairs. And those are electron pairs that are not bonding pairs. I would like you to draw the covalent bond for Cl2. Start by drawing your Cl atoms separately and then draw them together. You're going to draw it with all dots, and then you're going to replace the bonding pair with a dash. So the reason you start by drawing the separate atoms is you have to start by saying, do I have a full shell? And if you say no, you have to say, who can I share with in order to get a full shell? Does that make sense? So you say, do I have a full shell? No. Who can I share with? Oh, look, if these 2 chlorines each share 1 electron, they'll get a full shell. So that's what it should look like for chlorine. Is good? Okay. So this octet rule, they actually call it the octet rule, is that everybody except who? Needs 8 electrons to be stable. Who is the exception?
Helium.
Helium and hydrogen. And we're not actually going to worry about helium because we're not going to draw covalent structures for molecules including helium because helium does not bond. It's not very exciting. Okay? Everybody except hydrogen needs 8 electrons to be stable. That's what the octet rule is. It means you need a complete octet. You need 8 electrons. How many does hydrogen need? Hydrogen needs everyone. How many electrons does hydrogen need? 2. Okay, good. Now, can we make hydrogen and fluorine both stable by sharing some electrons here? Yeah, we could share here and here. That would give hydrogen 2, and it would give helium 8. Look at that. So we could draw it like that or like that. I would like you guys to try drawing a covalent bond formation in HBr. Start with the atoms. Do you think that you could figure out how to make oxygen and hydrogen work? Take a look at oxygen and hydrogen. Here's oxygen. If you're on your phone, that is not the thing to be doing. There's oxygen and hydrogen. Have we satisfied everybody? No, because that would give hydrogen 2, which makes hydrogen stable, satisfied. But what does oxygen need? It needs another one. So just like in an ionic compound, we can add an extra hydrogen. Okay, and you can actually see we will do that on the next page over here, where these two guys get together. Okay, and it doesn't matter whether you put them on the side and the side. It would also be okay if you put it on the top and on the side. And while we're here, how many bonding pairs does oxygen have? Yeah. Two bonding pairs. How many lone pairs on oxygen? 2. Does that make sense? That you should have 2 pairs and 2 pairs? You need to have some form of 4 pairs, right? So your homework is to do pages 96 to 97. And 90 to 91.
Thank you.
You're welcome. See you.